Namaste students, welcome back again in the RSU Group of School YouTube channel. Today we will start our next part number 7 of chapter number 10, Halogen. Students, in this video we will discuss about the physical properties of halogen. In this video we will discuss about the physical properties of halogens. Now let's start. The first one physical property is physical state. What is the physical state of haloalkane compounds? The lower members of the haloalkane compounds up to carbon 1 to carbon 5. The lower members of the haloalkane compounds up to carbon 1 to carbon 5 are the colorless gas at room temperature. वह रूम टेम्परेचर पे कैसे होते हैं? रंगहीन गैस की तरह व्यवहार करते हैं. From carbon 5 up to carbon 18, these are showing that sweet liquids. These are having sweet liquid nature. And above carbon 18, these haloalkane compounds are colorless solids. After carbon 18, these are the colorless solids. The next property is solubility, students. What is solubility? Solubility is the amount of substance dissolved in the liter water. That is the solubility. What is the solubility of haloalkanes? Haloalkanes are polar in nature. You know that haloalkanes are polar in nature. See, this is haloalkane compound and X is more electronegative, carrying partial negative charge, and carbon carrying partial positive charge. Due to their polar nature, they are soluble in the polar solvent but not. But the haloalkanes are not soluble in the polar solvents like water. See, haloalkanes are polar in nature, yet they are insoluble in water. Why they are insoluble in water? Because they do not have hydrogen bonding formation with the water molecule. The CH bond जो है हमारे haloalkane part जो है ये वाटर मोलिक्यूल के साथ हाइड्रोजन बॉन्ड का फॉर्मेशन नहीं कर पाता, हाइड्रोजन बॉन्डिंग नहीं हो पाती. इस वजह से हम ये क्या कह सकते हैं? दे आर इनसोल्युबल इन वाटर बट दे आर सोल्युबल इन ऑर्गेनिक सॉल्वेंट्स. दीज आर सोल्युबल इन ऑर्गेनिक सॉल्वेंट्स लाइक बेंजीन, अल्कोहल, etc. So what will be the solubility of haloalkanes, students? The solubility of haloalkanes is insoluble in water due to the absence of hydrogen bonding with water molecule, but these are soluble in the organic solvents like benzene, alcohol, etc. The next one property is density. What is density? Density equals to mass upon volume. Here the chloroalkanes are lighter than water. Chloroalkanes RCl are lighter than water, whereas bromides and iodides are heavier than water. Why the chloroalkanes are lighter than water and bromides and iodides are heavier than water? You see the order of density here. Ri, iodoalkane, having more density than bromoalkane. Bromoalkane is more density than the chloroalkanes. See, this is the example to show the density increase or decrease in the haloalkane compounds. Students, this is the CH2Cl2 dichloromethane and this is chloroform trichloromethane. In dichloromethane the density is 1.33 but in the chloroform it is 1.49. Why the density increases in chloroform? Because on increasing the number of halogen atoms in haloalkane compounds, यदि कोई हमारा हेलोजन कंपाउंड है उसमें हम हेलोजन कंपाउंड्स के अंदर हेलोजन एटम की क्वांटिटी बढ़ा दें, नंबर्स को बढ़ा दें, then the density increases. Here 2 chlorine atoms are present, here 3 chlorine atoms are present, so the density is maximum in the chloroform. Okay students, now move forward to a next property, that is dipole moment. Haloalkanes are polar in nature. You see here haloalkanes are polar in nature, but their polarity depend on the electronegativity of the halogen atom. Haloalkanes are polar in nature, you know that, but their polarity depends on electronegativity of the halogen atom. Halogen atom की विद्युत ऋणता इलेक्ट्रोनेगेटिविटी पे डिपेंड करेगी इसकी पोलैरिटी. सो डाइपोल मोमेंट को हम चेक करते हैं हेलोमेथिन्स में. डाइपोल मोमेंट ऑफ हेलोमेथिन्स आर एज फॉलोज. You see here the example chloromethane, fluoromethane, bromomethane and iodomethane, and the order of density are like as the dipole moment order are here. Chloromethane having high dipole moment than the fluoromethane, and fluoromethane higher than the bromomethane, and bromomethane having higher dipole moment than the iodomethane. Why? The fluoromethane having less dipole moment than the chloromethane. If fluorine having high electronegativity, फ्लोरीन की नेगेटिविटी इलेक्ट्रोनेगेटिविटी सबसे ज्यादा होने के बावजूद यह क्लोरोमेथेन से कम डाइपोल मोमेंट रखता है. इसका रीजन क्या है? द रीजन बिहाइंड इट द साइज ऑफ द फ्लोरीन एटम, बिकॉज द फ्लोरीन एटम साइज इज वेरी वेरी स्मॉल, ड्यू टू विच the chlorine compounds having high dipole moment than the fluoromethane compounds. Okay students, mark point and note down in the copy. And the last one property is the students, that is boiling point. It is very very important property, boiling point. What is the boiling point? Boiling point बच्चों होता क्या है? The substance which are boiled at the atmospheric pressure. When the vapor pressure of any liquid are equals to the atmospheric pressure, that point is known as boiling point. So what will the boiling point occurs in the haloalkanes? See, next point is boiling point. The boiling point occurs in haloalkanes in following ways. First one is for same एल्काइल ग्रुप्स. यदि एल्काइल ग्रुप्स कंपाउंड में सेम हैं तो बॉइलिंग पॉइंट किस तरीके से वर्क करेगा? लेट्स सी, हियर आई एम राइटिंग एन एग्जांपल, दैट इज CH3Cl, CH3Br, CH3F and CH3I. Here you see that the alkyl groups in each haloalkane compounds are same, all having alkyl group, that is methyl, having methyl group, fluoromethyl and again methyl group. Due to the same alkyl group, what will be the effect on boiling point? Students, note down that on same alkyl group, the molecular mass of the compound is increases, then their boiling point also increases. See here, chlorine is 35.5 and iodine having more atomic weight than the chlorine. So iodomethane having high boiling point than other compounds. The order here, CH3F having less boiling point than the CH3Cl, then CH3Cl having less boiling point than CH3Br, and CH3Br having less boiling point than CH3I, because this compound having more molecular weight. Due to the increase of molecular weight, van der Waals force of attraction also increases, and due to increase the van der Waals force of attraction, boiling point also increases. Now the second step, that is for same halogen. For same halogen, यदि हमने लिया सेम हेलोजन किसी कंपाउंड में, then what is the boiling point of that compounds? See here, that is CH3Cl, then C2H5 Cl, C3H7 Cl, and at last C4H9 Cl. Chloromethane, chloroethane, chloropropane, chlorobutane. Here the halogen atoms is same. इन चारों कंपाउंड में हम हाइड्रोजन एटम क्या रख रहे हैं? क्लोरीन रख रहे हैं, बट द कार्बन एटम इंक्रीजेज. सो व्हाट विल द बॉइलिंग पॉइंट ऑफ दीज कंपाउंड्स एंड व्हाट विल द ऑर्डर ऑफ द बॉइलिंग पॉइंट इन दीज कंपाउंड्स? See students, if the halogen atoms are same, then on increases the number of carbon atom, boiling point also increases. Due to which van der Waals forces increases, then boiling point increases. On here only one carbon atom, here 2, 3 and 4. So maximum boiling point in these compounds will be of chlorobutane. उससे कम किसका होगा? क्लोरोप्रोपेन. उससे कम क्लोरोइथेन एंड सबसे कम क्लोरोमीथेन का बॉइलिंग पॉइंट होगा, क्योंकि यहाँ कार्बन के एटम्स कितने हैं? यहाँ 1 है. ऑन इंक्रीजिंग नंबर ऑफ एटम्स ऑफ कार्बन, boiling point increases. So these are the two steps in which we conclude the boiling point. And the third point is, if isomeric haloalkanes is present. Third one is in isomeric haloalkanes. Isomeric means if branching occurs in the halogen compounds. Isomer का मतलब क्या है? यहाँ अगर किसी हेलोजन कंपाउंड में ब्रांचेस आ जाएं तब बॉइलिंग पॉइंट में क्या इफेक्ट होगा? स्टूडेंट्स नोट डाउन दैट प्राइमरी haloalkanes have high boiling point than the secondary haloalkanes. And secondary haloalkanes have more boiling point than tertiary haloalkanes. Why I write this order? Because on increasing branches in the halogen compounds, then the surface area of the halogen compounds become less and the molecule and the compound becomes more compact. Due to more compact and less surface area of that particular compound, the van der Waals forces decreases. Due to decrease of van der Waals forces, boiling point also decreases. So primary haloalkanes having a straight chain like this. This is the example of primary haloalkanes: CH3, CH2, CH2 and Cl. The example of secondary haloalkane is CH3, CH, Cl and again CH3. This is 2 degrees. This is 1 degree haloalkane. This is 2 degree. And third one is CH3, C, CH3, again CH3 and Cl. This is 3 degree. In 1 degree, no compact occurs. The van der Waals forces are more, then the boiling point is more. But in 2 degree, the compound is slightly compact. Their surface area is less than the 1 degree compound. And in 3 degree, the molecule is more compact and the surface area is very much less. The van der Waals force of attraction also decreases. So the boiling point in tertiary haloalkanes will be minimum. Okay students, so this is the criteria of boiling point in the haloalkanes, and these are the 5 physical properties which decide the physical state and properties of haloalkanes. Thank you students. We will meet you in the next video.